Lesson 22 workbook. We're going to jump down here to the last question, and it says a committee is formed from 3 seniors, 2 juniors, 2 sophomores, and 1 freshman. All 8 students are seated around a circular table. If students of the same grade level must sit together, how many different ways are there for the students to be seated? Okay, the first thing I'm going to note is that it's a circular table. So, with circular, the first question I'm going to ask is, does clockwise versus counterclockwise matter? And in this case, it's a yes. And that's because we're dealing with people, and it is not distinguished that they are interchangeable. So that's a yes. The second thing is we're dealing with grouping. So then we're going to find, because the grade levels must sit together. So this is how I think of it. Each grade level, there's in essence 4 general groups around this table, and I need to know how many ways I can sort those general groups around a table. So that's where the circular comes in, and I'm going to remember that it is our number of groups minus 1 factorial. So that's dealing with it being circular. And now dealing with the grouping. Alright, so within each of those groups, there's 3 factorial ways to arrange the seniors. There's going to be 2 factorial ways to arrange the juniors, 2 factorial ways to arrange the sophomores, and 1 factorial way, or just 1 way to arrange the freshmen. So now 4 minus 1 is 3. So we're going to have 3 factorial times 3 factorial times 2 factorial times 2 factorial times 1 factorial. And 1 factorial is just 1, but I'm going to include it anyways. So we have 3 factorial times 3 factorial times 2 factorial times 2 factorial times 1 factorial, and that's going to equal 144. Alright, so if we come down here, 144, we submit that for grading to make sure we're doing it right. Excellent. Okay, question 7. Which expression will find the correct number of distinct ways to arrange the letters of the word Arizona? B. Evaluate the expression you chose in part A. Okay, well the first one is, this is not circular, this is linear, and it's a permutation because it says arrange the letters. And now the second thing, so this is linear. And the second thing that I'm going to note is that we have repetition. So having it be repeated, how many? And is there more than one? Well, we have the A, and it's repeated twice. So for linear, we need to know what is our N, or how many objects are we dealing with. And in this case, we're dealing with the letters of Arizona, of the word Arizona. So there's 1, 2, 3, 4, 5, 6, 7. There's 7 letters in Arizona. So in linear, we could have 7 factorial ways of just rearranging Arizona. And then since we have 2 letters, 2 A's that are going to be the same, that are repeated, we're going to divide that by 2 factorial. And so we are going to check Google Calculator. We're going to have 7 factorial divided by, excuse me, divided by 2 factorial, and that's going to equal 2,520. And that's what it means by evaluate the expression. That means find the one number that represents it. So we have 7 factorial divided by 2 factorial for A, and we have 2,520 for B. So let's submit that and double check our work. Great job. Okay, question 6. You are making a necklace with a clasp. Okay, that makes a difference. For your mom, using 25 beads. There are 4 red beads, 6 green beads, 5 blue beads, 3 yellow beads, and 7 silver spacers. Which expression shows the correct way to find the total number of linear permutations of the 25 beads? And B, evaluate the expression you chose in part A. If you need help using your calculator to answer this question, be sure to ask your instructor. So we'll step through on how to do this. So we have even though it is a necklace with a clasp, so it's because the clasp is there, that, and since they said it's a linear permutation, we're going to use our linear equations. So there's the first thing is it linear or circular? It's linear because A, it says it, and because B, it has a clasp on it. And so then the second thing we know is we have groups. We have repeated items. We have 4 reds, 6 greens, 5 blues, 3 yellows, and 7 silver spacers. And so we're going to have to find the linear equation for a permutation that deals with groups. So our n is how many total objects? 25. And so there are 25 factorial ways I could find or arrange this necklace if I didn't have repeated items. I have 4 repeated reds, so I'm going to have to divide those repeated ones out. I'm also going to have to divide out the 6 green repeated beads and the 5 blue repeated beads and the 3 repeated beads and the 7 silver spacers that are repeated. Okay, so then it asks to evaluate. Okay, well, I'm looking at this and there's more than one number in the denominator. So we have 4 factorial and 6 factorial and 5 factorial. So I'm going to include parentheses around the entire denominator. If in the numerator it had 25 factorial times 3 factorial, we would include parentheses around that as an entire group because that's what parentheses indicate. It indicates that this is an entire group. So anytime you have more than 2 terms or anytime you have more than 2 numbers in the numerator or denominator, you're going to use parentheses. So we're going to come over here, 25 factorial divided by parentheses, 4 factorial, 6 factorial, 5 factorial, 3 factorial, and 7 factorial. That's going to equal 2.47 e to the positive plus 14. Okay, we need to discuss what does e mean when it shows up in a calculator. Okay, e means times by 10, and the positive 14 is the exponent, so this is a positive 14. And then we just have 2.47. So anytime you see e show up in your calculator with a number followed it, it means times by 10, and that number is the exponent for the 10. Alright, so we're going to look for 25 factorial divided by 4 factorial, 6 factorial, 5 factorial, 3 factorial, 7 factorial. That's what we did. And now we're going to look for approximately 2.47 times 10 to the 14th power. Okay. Great job. Okay. So again, E represents being multiplied by 10, and the number after E is your exponent. Okay, question 5. Which expression shows how many different ways 5 keys can be arranged on a circular key ring? Assume clockwise and counterclockwise are indistinguishable, and then evaluate the expression you chose in part A. So it is a circular key, circular, and clockwise versus clockwise, counterclockwise does not matter. No, it doesn't make a difference. You couldn't tell the directionality of it. So that means we're going to divide by 2 since they are indistinguishable. Okay, so then we have 5 keys. N is our 5. And our circular formula is n minus 1, so 5 minus 1 factorial. And since circular and counterclockwise would look identical, so you couldn't tell the difference, we're going to divide that whole thing by 2. So then this is going to equal 5 minus 1 is 4 factorial divided by 2. So then we're going to come up here to our calculator. 4 factorial divided by 2. That equals 12. Alright, so then we have 5 minus 1 factorial divided by 2 and 12. So we're going to submit this for grading. Great job. Alright, question 4. Which expression shows how many different ways 8 beads can be arranged on a bracelet with no clasp? Evaluate your expression. Okay, no clasp means it's circular. Does clockwise versus counterclockwise make a difference? And since there's no clasp, no, you would not be able to tell a difference in the bracelet or in the 8 beads, whether you put it on clockwise or you put it on counterclockwise. So since we can't tell the difference, we're going to divide by 2. So our circular formula, again, is n minus 1, and there's 8 beads, so that's our n. So we have 8 minus 1 factorial divided by 2. So 8 minus 1 is 7 factorial divided by 2. So then we're going to come over here to our calculator. We're going to type in 7 factorial divided by 2. That's 2,520. Alright. So now we're looking for 8 minus 1 factorial for answer A and divided by 2 for answer A. And we're looking for 2,520 for answer B. Great job. Okay, question 3. Evaluate which consider a Lazy Susan, which is a circular serving platter that rotates. A, which expression shows how many different ways 5 items can be arranged on a Lazy Susan, and B, evaluate the expression you chose in part A. Alright, so it is circular. So that's the first thing. Circular. The second thing, does clockwise versus counterclockwise matter? That's a yes. We're not dealing with the identical items going clockwise versus counterclockwise, we would be able to tell a difference. So yes, so then we do not divide by 2. So then our circular one, our n is 5 items. So our circular pattern would be n minus 1, so 5 minus 1 factorial, which equals 5 minus 1 is 4, so we would have 4 factorial. And let's go and evaluate it. So 4 factorial is going to equal 24. And so we're going to have 5 minus 1 factorial. It's not divided by 2 because clockwise versus counterclockwise does make a difference in our permutations. And we're looking for 24. Great job. All right, question 2. Which expression shows how many different ways 8 people can sit around a circular table? Evaluate the expression you chose in part A. All right, circular table. So it is circular again. And does clockwise versus counterclockwise make a difference in our order of permutations? And that's a yes. Because we're dealing with people and it's different having, even if you have the same 2 people next to you, it's different. Say you had Bob and George, and Bob was on your right hand side and George was on your left. That's going to be different than having George on your right hand side and Bob on your left. So yes, it makes a difference. And then evaluate. So it's circular, so I need my n, which is the number of people we have, which is 8. So our circular is n minus 1, so 8 minus 1 factorial. And that's going to equal 8 minus 1 is 7 factorial. And so then we're going to come over to our calculator, 7 factorial, and that's going to equal 5040. Okay, so we have 8 minus 1 factorial, and we have 5040. All right, good job. All right, which of the following situations can be modeled by a linear permutations? Okay, so linear permutation. Is there a distinct start and a distinct end? Assigning seats for wedding guests around a round table. No, there's no distinct start and end. Assigning seats at a wedding for the rectangular head table so that the wedding party sits at only one side of the table. Yes, even though it would is rectangular, if you had people sitting around it on all sides, there would still be no distinct start and end because it's in effect a circular. But because it says on only one side, that's going to eliminate those. So there is a distinct start and a distinct end on that case. And then arranging unique beads on a necklace with no clasp. Okay, no clasp, that means that there is no start and no end to be determined. And then arranging books on a bookshelf. I would say yes because it's going in a straight line. All right, let's check that. All right, great job. So there's your workbook helps for lesson 22.